So essentially where I'm going to start is the architecture of the model so we can understand how everything fits in with each other. And then I'll go into the actual practical demonstration of the tool. So we start off with all the inputs that we need for the model, right? So it's all your locations, suppliers, manufacturers, DCs, the customers, whether it's stores or shops, products, supply lead time. And most of these things comes from some ERP system, whether it's SAP or something else. And typically these are exported. If they're small enough, we can put it all in an Excel file. If they're significantly larger than 1,000,000 rows, then we go into CSV files or just text files, and we zip all of them into a single file and then feed that into the model. So in the Excel file or the CSV files, you also get to add in some additional information that's typically not available in your ERP system, like what's my supply and demand variability, right? Or what is the forecast error that I want to simulate, especially if you're going to simulate some future, right? We want to simulate the next year's forecast, or we want to add in a new DC. And this is what we think the variability would be on supply lead times from suppliers, right? So there's some additional information that you add in also into the Excel or the CSV files. And then all of this gets put into the supply chain digital twin or SCDT, and then the model gets created dynamically. Your entire network gets created from that data. Now, on top of this, we also add in whatever the questions is that you want to simulate, like I want to change my specific inventory management rules. I want to change some sourcing policies or some delivery policies, etc. So what essentially the business questions are that you want to answer with the supply chain twin. So when we run the model, we essentially build all the events. And I know there were some questions previously about like macro level, micro level. What we're simulating is like the micro level. You've got your demand forecast. We generate the demand from that, or we've got only demand, and then we to create a forecast if it's needed. We simulate each individual customer order. We simulate the fulfillment strategies, whether it's make to availability, assemble to order, or make to X, which is essentially making up to a specific point. So we had this example with Microsoft when they're building the Xboxes for the Christmas period. In the period preceding that, they will have specific inventory levels that they're trying to hit instead of just producing everything in one batch right before the Christmas period. Transportation in an intense amount of detail. We model full truckloads, less than truckloads, parcel shipping. What's the cost structure? Is it by mile? Is it by pound? Is there a fixed portion? Is there different brackets? How are you going to simulate that? So that if you've got a question about where you should locate your DC, how many DCs, or how you should allocate customers to DC, the eventual transportation cost needs to be simulated in what the actual calculation would be once you get there. You can't use averages. You can't use some assumptions. And we've had this project that we did with one of our book supply customers where they had this high level estimation of where the location should be and how they should transport. There was different methods of doing this. And by using the averages, they got to this answer where, oh, they should include these additional locations. It will save them a couple of $1 million. And when we did the simulation, we said, listen, this is actually going to cost you a lot more. Because if you just use the average supply fill rate for your trucks, it seems like it's a good idea. But due to the seasonality and the demand variability, etc., you won't be able to always fill those trucks to their full capacity. And so you end up actually costing you a lot more. So it was better to drive further distances, do bigger batches, etc. And you can only do that if you're simulating the transportation at that level of detail, the customer demands, the actual detailed, time that the order gets placed, how long can you wait before you have to pack it into a truck, etc. And also we simulate a lot of the tariff constraints and other supply chain management best practices, whether it's DDMRP, prioritization rules in manufacturing, as well as transportation selection and sourcing rules as well. When you run the model, we get a lot of in-app reports. We've got some nice charts and some graphs and things that you can have a look at to see whether you're simulating what you want and what is the impact of the changes that you've made. Then there's Excel reports and detailed log files. And as I explained to somebody earlier in the week, like these log files are really the biggest benefit of this, because we provide you such a lot of detail that whether it's different customers, whether it's different projects, or in this one project I'm doing now, for 5 of the scenarios, I analyze the log files using a specific script. And for 2 of the scenarios, a completely different script, because it's something completely different that we want to look at and see what's the impact. But because we provide you all these low-level outputs, you're able to do whatever analysis you need from them. Inside the application itself, we've got the single run functionality, which I'll demo in a lot of detail now. So you get to see things moving, all the charts and how everything fits together. Sensitivity analysis and scenario comparison. So for sensitivity analysis, if you want to change a specific parameter from a range, from minimum to a maximum with a certain step, Scenario comparison, completely different files that you want to compare. These typically run without any animation, and we just provide you the key performance indicators, summary at the end, and the low-level log files. Architecture, I think one thing I just need to mention as well is this. It's a standalone Java application that you just download as a zip file, unzip it to your computer, and you get to run it. And depending on how big your computer is, in terms of RAMs and CPU, that's how much performance it can provide you, depending on the hardware. And then the data files, again, you import your data files, and depending on how much memory you've got, that's the size of the simulation that you can run. So there's no like it's a cloud solution and it's hosted somewhere and you need to have some database in the back end. You can feed it with whatever data you've got and then run it on your desktop, or for big simulations, we always run it on a server. So next up, I'm just going to do a brief overview of what you'll see in the simulation when we start running it in single run mode. So here on the top left-hand side is like a high-level supply chain overview, where you get to see all the locations and what's the inventory values and orders, etc. We've got the full financials here just below it. Then here at the bottom in the middle, we've got product at location tables. So for every single product location at the suppliers, plants, DCs, customers, etc., you can dive into the detail for each one of those. You can view the average and overall view for every single customer, and then view the detail, trace the product back from the customer to the DC, to the plant, to the supplier, etc. Here in this middle view, we show a lot of detail for that specific location, that product location that you've selected. And on all of these charts, you will see there's always like a red line and a blue purple line, the red line being the actuals. So for most projects, at least the first phase of the project is always simulating the historical. So we re-simulate your last year, and we say, how much better could you have done if you changed the rules, if you changed the design, if you changed your inventory management policies, or whatever the case might be. And then you can directly compare the actual inventory levels versus your simulated inventory levels. Or as we do here on the right-hand side, your sales at risk. So the sales at risk is a measurement that we developed to say, when you've got a stock out, how much sales did you put at risk, right? So if you had a preceding sales velocity before you had that stock out of, let's say, 5 units per day, and every unit sold for $1, every day that you stocked out, you're running the risk that you could have made $5 of sale that day. So if you're out for 10 days, there's $50 of sales at risk. And we compare that for both simulated and actual. So you can see in this example I'm showing on the screen, we managed to put less sales at risk by either having less stockouts or not having stockouts during key periods when there's high sales velocity. And the chart below is the inventory value. And all of these things we show in value and units, etc. And essentially what we most of the time trying to do in most of the simulations is trying to show if you can achieve lower inventories with also lower sales at risk, right? So we're trying to reduce surpluses and also reduce shortages. Most of the times, that's what we do with the inventory management rules that we change. But a lot of our projects is also a question about design. Where should we place the DCs? What's our transportation cost going to be in the future once we take on this market? If we increase our product mix, etc. The nice thing about our platform and our architecture is like what I'm showing you now is our generic supply chain twin. And then we take this application and we create an inherited project from it. And then in this project, we can put in specific customer logic, maybe something that's proprietary to the way they do things. We can override things from the core model that we don't want here. We can add things that's like special for this specific customer that we're modeling. So we end up, as you can see at the bottom of my screen, multiple different versions of SCDT for different clients, which contains some unique logic, some branding for them, something that's proprietary to them, etc. But this clean version, like this is a version we can provide you as well, and you get a trial license that you can use for that. You can open up some of our standard scenarios that we've got here. As you can see, the model is completely empty. If I go to the scenario editor, there's nothing. And now I just upload this zip file, which contains our demo for today. And the model reads in all the data, builds the network, places everything at the right location, input all the links for us, different colors for different kinds of links, making adjustments and customizations to the app, to the platform. And the nice thing is that if we create this inherited project for you or for your, that you're going to use for your client, you get to make changes in there, create new versions of that specific project for your client. And there would obviously be some hand-holding in the beginning, but the idea is that you'll be able to add in those customizations for yourself, or if it's something too complex, that we'll have to do that on the core model for you. We've got an entire team, our partners that provide the low-level base platform for the simulation amalgama. There's like a team of 12 developers working on this and various other simulation tools that we've partnered on with them. So those kind of customizations is in already, most of the things. It's easy enough to just add those additional rules. So here, for example, I've got like sourcing rules for the DCs, where I say filter to only source from the plant. And we can say, or do this only, so source from the closest or cheapest location if you are in the green. If you are in the red, source from the fastest location, like that can supply you the fastest. And same in delivery, etc. So we've got a lot of these sourcing and shipment rules that you can configure in a great amount of detail. Where you can input, I want to put some numeric priority where I say, what is the relative to the order quantity, relative inventory, minimum total cost, maximum total cost, right? Estimated planned delivery time, etc. So there's a lot of rules that you can input for sourcing and shipment that we've already catered for because it was used in various previous projects. And we're always keen on increasing the features that we've got, especially if it's a real client needed feature. We will obviously want to invest in that because there's a real need for that. And typically when we get a project with a client and we say, okay, this is what they want to simulate, we're like, okay, what additional features do we need? Okay, this is going to be some generic functionality. We'll do it at our cost, or we'll quote the client something to get that developed, right? So we are very keen on making adjustments. And if you compare us to like somebody like Alamasoft, if you give them a call asking for some custom functionality, there's no way they're going to be built that. Where we create bespoke versions of our software for specific clients to answer their specific needs. We're doing something currently now with one of our book publishers where they're saying, if at the shop they're going to sell less coloring books, like they're reducing the SKUs, then they also sell less coloring pens. If you're removing things, you're changing the basket of sales. Now we had this question, okay, if we reduce the coloring books, how much do you think it will impact the pens by? But with that like milk example, you can say, at what, if you're selling milk at a loss, how many additional products should the customer buy in order to make up for that, right? So you can answer that what if question. You can say, okay, well, if I were to change something on the milk, what other, product should I be buying, or how can I get the break even point? So that's one way that you can simulate to say, well, I'm going to be selling my milk at a different price. Now people might not buy it, or it's going to have some change in transportation. What's that break even point? And then typically the marketing people will say, okay, well, no, I think that's fine. We should be able to make that additional sales on other items. I'm going to just dive into some of the functionality that we get here on the editor page. The one is the ability to edit things directly here in the editor, right? If you want to make changes to, let's say like now I'm making changes to this demand forecast. You can also load directly from CSV and text files, especially if it's like bigger than 1 million lines. We can edit it directly inside Excel. And so for like our steel supply chain customer that's using this on a monthly basis, they would often, just open this in Excel, make whatever change it is that you want to make, or copy and paste it from the ERP system, upload it back into the model, and you can see the changes that I've made now with that 1,500 and 1,000. For this specific demo, we're just reading in the forecast, and then we are generating our demand from the forecast for these customers. We've got some storage and handling costs, by unit of product, and you can specify it by some other capacity like weight of the product or pallets. That's what we normally have. Like most of these warehouses, as we're modeling now, charge like a couple of dollars per month per pallet. We've got our transportation cost. So like you can have a cost per run, a cost per capacity unit. We've got costing table records. So you can say, so for example, the UPS costing table records is there's a fixed cost for up to £3, then up to £5, then up to £7, etc. So we've done a number of models where we just use those rates. And there's by distance unit and capacity distance units. And if you've got multiple ways inside this one line to calculate, do we use the sum or do we use the maximum or even the minimum? And that's what you get paid. So there's a lot of detail. Transportation has been something that we've simulated in a lot of detail in a number of projects in the last couple of years. Okay, and so when everything's ready, we hit simulate, it does a detailed check on the scenario, validating everything. If there's any issues, it gets shown in this little error file. And if I start running the simulation, you'll see lots of, these are just orders moving from the different suppliers to the plants, DCs, customers, etc. So to start off simple, I'm going to have a look at this China DC. Let's have a look at product one. I'm just going to put it full screen. So you can see we've read in the historical actuals, that red line, and now we are simulating with the blue-purple line, the simulated inventory. So historically, they used some min-max. So you see, infrequent orders, huge orders, up to like, say, 3,000 or 4,000 units at a time, where now we've got much smaller quantities, less than 1,000 units, and we're placing orders, I think it's daily on this one. And these red, yellow, and green zones that you see comes from the theory of constraints dynamic buffer management system, where green obviously is the top, yellow in the middle, and red. And you can see immediately what's happening here is if we are running this smaller, more frequent order placing, we get much lower inventory levels. So at this level, at this stage in the model, it's like 30% reduction in inventory. And if we keep on running it, you'll see we never have a stock out. where due to this like sawtooth inventory levels they've got, there's been a number of stockouts and they incurred some sales at risk, where currently in the simulation we haven't achieved any sales at risk. And we can just speed up the model a little bit to show how this is running. Okay, so I'm looking here at another product. This product is a product with end of life. So in this instance now we ended with slightly higher inventory levels than what they did. Let's have another product. This product had some seasonality. So you see if we end up having too much red penetration, so the inventory levels spend too much time in the red, it automatically adjusts based on the theory of constraint rules, your target stock level. And so now we increase our target stock level, keeping more stock, then that sort of period is passing, then we lower the target inventory again until here we get too much red and we start increasing it again. And this rule runs in fully automatic mode. You can see the parameters of the rule here. If you go to the setup pages, it's written out in like a text format. It's saying check every day for this and increase the target stock level by that. And we've got this for DDMRP, the TOC rules. We've got min-max and EOQ as well. And you can see here exactly how this panned out for the simulation. We can also view a lot of detail for the specific product. So we can see the A3 product, it was supplied by the suppliers here on the left-hand side. So this United States supplier supplied this DC. This DC is connected to 10 customers. And we can see who those 10 customers are. There's another supplier. This supplier also supplied 2 other DCs, their customers. There was also a DC that was supplied by this plant, this portion in the gray area. And this is now not showing you the full detail because we're looking at this product graph. If we go to a specific customer, so I'm going to go into this specific customer, we see how their inventories reacted. And now we can look at the full product graph. So it's showing you for this final location, what's all the different routes you can take to get there, and how much was passed through each one of these routes. You can see nothing went through the suppliers, everything went through this plant. At this plant, we've got raw material suppliers, raw material stock inventory that we're keeping of X and Y. We've got our processing centers, X and Y, that's producing component AX3, AY3, and they get combined, another processing center, into product A3. So we can go and have a look at this inventory levels. This one is a bit of a special product. If we have a look at the raw material, we can see that they managed very similar to what happened in the actuals. And we can go into the detail of that specific plant. Let me just get to the plants. And we can see what was the utilization, what's currently in the backlog, what's the color of these orders. So black means that it's late, red means it's about to be late, yellow, it's sort of in the middle, and green. We're going to have a look at the detail of this specific processing center. So we can see here, let me just increase this portion here. Wow, how much time was it spent producing a batch? There was some planned unavailability, it was idle. So we at a bit of a higher level for the processing centers, you can input of unavailability, mean time between failures and mean time to repair, planned unavailability patterns. We can see total production lead time. Here you can see what was the backlog at the end of the day throughout the simulation period for this processing centers. You can see there was a lot of blacks in the beginning, so it was high demand. And then it took us some time to work through that backlog until there was like only yellow and green. And then there was a significant backlog period here as well. You can view all the batches, all the orders that was completed, etc. So if you've now viewed all of this in single run mode, you've made sure that everything is comparable to your historicals, everything makes sense, you've set up the model correctly, we can now easily go back here and make some changes. So for example, let's change our inventory management rules, like the raw material or the DCs, we're going to change this rule. Let's say here in planning, there's something that we want to change here, or I'm going to make a big change this back to min-max at the DCs, for example. And I now just save this as a new scenario, test min-max, and we go to our scenario comparison functionality, and I upload the 2 scenarios that we've got, and we compare them against each other, right? So typically there would be a lot of scenarios that you want to compare. If it's different layouts, different inventory management setups that you've got, etc. I just want to show the product mix optimization as well. So yeah, I've compared these 2 scenarios, min-max versus the TOC rules that we've got. So you can see service levels are down, average inventory is less, which makes sense because we're having stockouts, and that's why the service level is lower. Inventory turns slightly higher because of the low inventories, but sales revenue is lower and lots of sales at risk. So, and all of this you can view in Excel. You can use the log files to further analyze your scenarios. We've got a parameter optimization mode as well. if you want to test something, let's say for the DCs, I want to test, I want to look at the maximum average service level, then minimum total inventory value. This is just going to sort all the options. So a little bit of a brute force optimization. So we can test DOC buffer penetration, and we want to test these parameters, and it sets up all of these for you to run automatically. And then you can see what is the best, based on the criteria that you specified, parameters for my inventory management rules that I've set up. And this is very valuable when we're doing like future case scenarios with people saying, this is the new products that's going to come out. We expect, plus or minus 30% forecast accuracy in these regions and in those regions, etc. What can we reasonably look at average inventory levels, etc. Okay, and what if we enable this method of transport? Okay, what if we add a local distributor there as well to keep stock closer to the clients?